Pharmaceutical Chemistry for the Telangana Pharmacist Examination. So this model paper that is specially designed by the expert faculty of ZDC to target your upcoming Telangana Pharmacist Examination. So in this part, we are going to discuss the top 20 questions from your pharmaceutical chemistry. Pharmaceutical chemistry basically include your inorganic chemistry as well as your medicinal chemistry, physical chemistry, organic chemistry, and few about the biochemistry. So as in the part first, we had discussed the 20 questions. I hope you had enjoyed that session also, and I will promise you that you are going. I'm promising you that you are going to enjoy the session also, as you had watched the first part, and I hope you are also going to watch this part in a very honest and disciplined way. If you are having any doubt, you just drop a message in the comment box. When we watch your message, when we watch your comment, we are definitely we are replying. So, dear student, first question for you, like the ring present in the methimazole. So, which ring is present in methimazole? So, methimazole, that is basically your anti-thyroid drug that is basically used in your hyperthyroidism. So, this is the drug that is used in hyperthyroidism. We have the drug like carbimazole that is usually available in the 5 mg and 10 mg, as our carbimazole is having the side effect that agranulocytosis sometimes occur, and sometimes gastric irritation also occur, and this drug is also belonging from the same category as our carbimazole. It is an anti-thyroid drug basically used in the hyperthyroidism. So which ring is present in this? So just remember IMAZOL is here. IMAZOL is here. So just remember that imidazole, that is the ring present in your methimazole, you are typically able to see that we have the pyrazole that is having the 5-membered ring structure having 2 nitrogen. Next we have the thiazole having 5-membered ring structure, sulfur as well as your nitrogen as the heteroatom. Next you have again 5-membered ring structure having the 2 nitrogen at the 1 and 3rd position. At 1 and 3rd position there are the 2 nitrogen. At we have the pyrazine. Pyrazine is also having the 2 nitrogen having the position at 1 at 4th position. So 3 methyl and 1 hydroxy imidazole 2 thiophene, that is the structure of your methimazole. So which of the following are the name of the cyclic ether? So cyclic ether, we can say like this, like which name we can give? Like the ring having the 5-membered ring structure, or we can say heterocyclic atom, oxygen. So for the 5-membered ring structure having the oxygen as a heteroatom, we can say it is furan. So just you have to remember this point also, like this we can say the structure, or we can say cyclic ether, we can say it is oxirane. Oxirane is the cyclic ether. So basically cyclic ether, that is the simplex, it is the simplex epoxide that is having the 3-membered ring constituent of 1 or 2 oxygen atom and 2 carbon atom. And ethylene oxide is a colorless flammable gas with fainty sweet odor, and it is having the oxacyclopropane, that is the exact chemical name of your oxirane, or it is the simplest cycle ether. We can say like this is the simplest form. Like to form a cyclic structure, there is a requirement of at least 3 atom. Like in this structure there is 3 carbon. If we are just taking 2 atom major atom, then it is not possible to make the cyclic structure, and for make one more, like there is a need of 1 carbon more. Got it? Next question for you. Which of the following pair of drug is considered as a selective alpha 1 blocker? Selective alpha 1 blocker, that is your prazosin and terazosin drug. Selective alpha 1 blocker, that is prazosin and terazosin drug. That is non-selective alpha 1 and alpha 2 blocker, and it is selectively like alpha 1 you have the prazosin, terazosin, doxazosin, tamsulosin, alfusin, and alpha 2 that is the yohimbine, and non-selective we have the reversible and irreversible. Reversible we have the phentolamine and tolazoline, and irreversible we have the phenoxybenzamine. So this is the typical representation classification of your alpha blocker. So we have prazosin, trazodone, that is basically used in your BHP, that is benign hypertrophy of prostate. And prazosin and trazodone are only recommended to those patients that are having the hypertension along with their BHP. That is benign hypertrophy of prostate, in which the size of prostate gland is going to be increased. Or yoimbine, that is the most important, that is it is selectively beta 2 alpha 2 blocker. Next, we have the ring present in diazoxide. So diazoxide is having the ring. Diazoxide means there is a two nitrogen. Azo, as I told you in the first part also, like azo, that is the word used for the nitrogen. Di means two. So there is the only single option, whereas you are able to see diazine means this is the benzothiadiazine, in which there is the two carbon. You are able to see dia means two, azi means nitrogen. So I think you are clear with the concept. If aza in the group means there is a nitrogen, thia in the group means sulfur. If both in the group, thia, aza, then it means both sulfur and your azine is there in the group. So this is the typical structure of a diazoxide, having the benzothiazide ring, having the two oxide dioxide as the sulfur position, chlorine at the 7th position, methyl group at the 3rd position. And next you have to find out the given structure. You have to find out the given structure, like chlorine you have, and this is like you have the benzene ring, and there is a ethoxy group is there. So this is the basically structure you have to remember, that clobifibrate means there is a chlorine group is here. You have to remember that clobifibrate. You can just use your smartness. Cl is here, Cl is here, so you can take that clobifibrate, that is the structure that is showing. So the clobifibrate is having this structure containing two methyl group, whereas our gamifibrosil is also having this structure having the benzene ring, and ciprofibrate is also having the benzene ring, as well as one more cyclic ring it have, like tricyclic ring is it have. And like clobifibrate, that is your anti we can say hyperlipidemic drug. We can say it is used for the patient having the high cholesterol and triglyceride level. So it is basically act by the bile also. Next you have to find out the given structure, like the given structure is showing of which compound. So you are able to see that this is the 6-membered ring structure having two nitrogen. We can say two nitrogen act as a heteroatom and having the two oxide group, and one phenyl and one ethyl group is attached also with the carbon that is having in the benzene ring, in the 6-membered ring. So this is the basically structure of your phenobarbital. Phenobarbital, that is we can say your barbiturates that are basically used as a sedative, hypnotic, as well as antiepileptic. So phenobarbital, as the name indicate, pheno means like there is a phenyl group is there, that's why it is used as phenobarbital. Next you have the hexobarbital, means there is a hexane ring is there. Hexane ring means there is a single bond is there. Next you have barbital. Barbital means there is a two methyl ethyl group is there, like two ethyl group, it is barbital. If one ethyl group and one phenyl group, it is phenobarbital. Next you have hexobarbital, means there is a hexane ring and one double bond. Next you have the cyclobarbital. Cyclobarbital means same, that we have the ring 6-membered ring, and there is a difference between the hexobarbital and cyclobarbital, that at the nitrogen at first position, in case of hexobarbital we have the methyl group, but at the first position in the case of cyclobarbital there is no methyl group, only hydrogen is there. Got it? Next you have the stannous chloride. This question is from your dental-physis. So stannous chloride is used as, you have the option, like it is used as an astringent. Astringents are the compound that are used to precipitation of the protein. Next your dental caries that are used to clean up the teeth. Dental-physis are the product that are used to polishing and all the things. Anti-dandruff are the agent that are used to red away, or we can say take out the dandruff, and there are basically include our sulfide, or we can say our ketoconazole, our salicylic acid, our zinc pyridine. These are the compound as well as the drug that are used as an anti-dandruff. So stannous chloride, that is basically used as a dental caries agent. So dental caries are the those agent, or we can say tooth decay, that is a disease, or we can say a less disease of teeth, that is caused by your acid production by the action of microorganism on the carbohydrate. So basically anticaries include your sodium fluoride and your strontium fluoride. Next, you have the principal neurotransmitter in the cholinergic system. So cholinergic system, like basically we have the parasympathetic system, parasympathetic, and sympathetic system we have. So the principal neurotransmitter in case of cholinergic, or we can say parasympathetic system, we have the acetylcholine. Acetylcholine is released always, we can say presynaptic neurotransmitter is always releasing the acetylcholine as a major neurotransmitter. And next we have phenosuximide, that is also a useful drug. Atropine, that is your we can say anticholinergic drug. We have atropine, that is used as in many cases. Next, we have like cholinergic transmission. As I told you, acetylcholine is a major neurohormonal transmitter at a autonomic and somatic as well as the central site. Acetylcholine is synthesized locally in the cholinergic nerve ending by the following path, like ATP in presence of acetate and coenzyme in presence of acetate activating and reactions, and then further it react with the chlorine and choline, sorry, then choline is converted into the acetylcholine, and in presence of choline acetyl transferase there is a formation of acetylcholine chloride. So identify the structure name. We have the structure, typical structure we have, and you are able to see the option that we have captopril, enalapril, lisinopril, and quinapril. So both like all the four drugs are from your ACE inhibitor, means angiotensinogen receptor antagonist. Somehow these are the drug for your hypertension. Having the side effect, that is angioedema, dry cough and angioedema are the side effect of these drugs. As we have the captopril and enalapril, these are the two drugs that are active. Other drugs are prodrug, and they are going to be active when we are taking it. So the given structure of we can say the given structure is of your captopril, that is the prototype drug of ACE inhibitor. ACE inhibitor are strictly contraindicated in the pregnancy, as well as the patient is that is having the renal transplantation or kidney failure. This drug is strictly contraindicated, and as I told you that there is a side effect of these drugs like angioedema and dry cough are the side effect of captopril. So captopril is the active drug. It is not a we can say prodrug. So we have the prodrug lisinopril and qualpril, ramipril are the your active prodrug. Captopril and is enalapril are your we can say active drug. They don't have to need the convert into the active form. So captopril, as you are able to see that there is a pyrrolidine ring and having the carboxyl acid at the second position. Then after we have the enalapril. Enalapril is also having the pyrrolidine at the second position. It is having the carboxylic acid. Then after you have the uh, quinapril. Quinapril is also having a typical structure containing phenyl butane ring as well as one benzene ring is there, and isoquinoline is there. Isoquinoline is present, ring is present in your quinalpril. So this is your isoquinoline ring. This is your benzene ring. And whereas the lisinopril is also having the typical structure containing one benzene ring, one phenyl ring, as well as the one pyrrolidine ring. One pyrrolidine ring and one phenyl ring is there, and there is a straight carbon chain of 6 carbon. So this is the typical representation of a lisinopril. Next, we have the 10th question. Like you just have to identify the IPSC name. So IPSC name here we have 2,4-diamino. Means at the fourth, we can say we have the 2-amino group. 2-amino at second and fourth position. Next, we have the piperidine. 6-piperidine we have, and pyrimidine 3-oxide. So pyrimidine 3-oxide, we have the 2 nitrogen. So this is the structure of your minoxidil. Minoxidil, like this is the typical structure. You are able to see that there is 2 and we can say 2 and 4th position there is an amino group, and piperidine ring is there at the 6th position. Pyridine, that is the main ring, and oxide at this first position. So minoxidil, that is your potassium channel opener. that is also the antihypertensive drugs, but now the time minoxidil is having the side effect of hirsutism, so that's why minoxidil preparation, topical preparation, is used in case of baldness, or we can say in case of androgenic alopecia, juvenile onset alopecia, and elder alopecia. So in all the alopecia, minoxidil is usually using in 5% concentration in we can say topical formulation along with the finasteride, that is usually in the 0.1% concentration. So minoxidil, that is we can say in the same category in which nicorandil, that is also in the same category that we have the minoxidil. They both are our potassium channel opener. Potassium channel opener we have, and another drug of same category we have second drug, that is nicorandil. Nicorandil. So these two drugs are your potassium channel opener, and minoxidil, one of them, is using in a case of alopecia in treatment of different type of alopecia in topical formulation. Next you have the hydralazine. Hydralazine is also your we can say antihypertensive drug, and it is having the phthalazine nucleus. Phthalazine nucleus is in your hydralazine, and there is another drug, that is diazoxide, having the benzothiazine ring, and next you have the losartan. Losartan are your we can say angiotensin receptor antagonist drug. We are basically a telmisartan, omnisartan drug that are basically available in the 40 mg and used as a antihypertensive drugs in the patient of having the high blood pressure. Next drug you have, student, this is the most important and basic questions, like you have to tell me the IPSC name of paracetamol. Paracetamol that you are using. So paracetamol, that is the drug that basically having the property of the fever, we can say, sorry, anti-analgesic and antipyretic property. Paracetamol basically we have the antidote for the paracetamol toxicity, that is N-acetylcysteine. So paracetamol is causing your liver toxicity, and maximum dose of paracetamol if a adult patient can take is 3 gram, or we can say 4 to 5 dose of paracetamol in a day, 650 mg or 500 mg a patient can take. Up like above that, there will be chance of the getting nausea, vomiting, and sometime at severe dose it will cause your liver toxicity definitely. So IPSC name, as you know, there is a ethamide group is there, and there is a phenyl ring is there. So this is very important. Definitely they will ask in this your examination. There will be probability that they will ask about the prototype drug. Prototype drug are the main drug, like we have the acetylcysteine, atropine as an anticholinergic, adrenaline as a sympathetic. Next we have the propranolol as a non-selective beta blocker. After that we have the sodium valproate as an anti-epileptic, we can say levodopa as a Parkinson's. After that depression we have the in the depression we have duloxetine. After autocoids we have the phenanthrene, citrazine. So they can ask the prototype drug. They can ask for the ketoconazole, sulfonamide drugs. So the IPSC name of your sulfonamide, you have an N4-hydroxyphenyl ethosuximide. That is your IPSC name. So paracetamol, as you know, it is also known as acetaminophen. So in the exam, the question is like that, acetaminophen is also known as, so you have to tell them that it is a paracetamol and is a medication that is used to treat the fever as well as mild to moderate pain it can treat. Common brand name include your Tylenol and your Panadol. Tylenol and Panadol are the common drug, that is common brand name of your paracetamol, and paracetamol is commonly prescribed drug for the mild to moderate pain and the fever. And this is the pain include like your headache, your body pain, and of your any acne on the muscles. So this is the typical diagrammatic representation of this structure of your paracetamol. You are able to see the hydroxy group at the 4th position. This is your first carbon, second carbon, third carbon, fourth carbon you have, and 5th carbon and 6th carbon you have. And this is phenyl ring, and this is the acetamide group. This is the acetyl group, and this is the amide group. So the IPSC name of your paracetamol is 4-hydroxyphenyl acetamide. Got it? So next question for you, azolidine. Azolidine can be termed as azolidine. Azolidine. Azo means that like there is a nitrogen in the ring. Lidine. Azolidine. So this is your pyrrolidine. As I told you, like pyrrole is the pyrrole is having the nitrogen at the heteroatom and having the 5-membered ring structure, and azo, that is body for the nitrogen leading, that is same in this compound. So for these questions you just have to use your basic skill and your smartness that you have to show in your examination, because the smart study is very useful for your examination. So pyrrolidine, you know very well, it is known as tetrahydropyrrole. Tetrahydropyrrole is the name of pyrrolidine. It is an organic compound with molecular formula that is CH2 whole 4 NH, and it is a cyclic secondary amines, and it is classified under as a saturated heterocycle, and it is a colorless liquid that is miscible with the water and most organic solvent, and it is referred as a pyrrolidine. Pyrrolidine, that is the actual name of your we can say IPSC name of your tetrahydropyrrole. And other name of pyrrolidine, that is your azolidine, that was asking the exam, that is in the questions, azolidine, and also known as azocyclopentane. We have the another name of pyrrolidine, that is tetrahydrofuran. Next name like pyrolamine or azolane. That is the structure of your azolidine. So you just have to remember each and every point that I am going to tell you. Either it is written in the slide or not. Just you have to remember each and every point. So next question for you, we have to just find out the given structure. Just we have to find out the given structure. So given structure is having the 2 nitrogen as a heteroatom in the structure, and it is containing the 3 oxy group. So basic structure is your barbituric acid. Barbituric acid that we are basically using as an anti-epileptic as well as sedative hypnotic. So this is the typical diagrammatic representation showing the 1 and 3 position as a azine, and 2, 4, 6 that is trione. We can say 3 oxygen group are attached to the direct 6-membered ring structure. Next to have, what does a positive value signify? We can say, what does the positive value of sigma signify for a substitution? Like this question is from your from your SAR. We can say structure activity relationship that you had discussed in your medicinal chemistry syllabus. So what the positive value of your sigma? So is it telling about the electron withdrawing group? First option we have. Second option we have, it is telling about the electron donating, like it is neutral, and next you have it is hydrophobic. So basically the positive value, as you know, of sigma is telling us the electron withdrawing ability. So the substitution constant that is represented by sigma, that measure the electronic effect of the repelling hydrogen by given substitution, or we can say the substitution at the para and meta position in a compound. And the negative value of the sigma that describe the electron donating substitution, whereas the positive value is describing the withdrawing substitution. So in this question they are asking about the withdrawing effect, or we can say positive effect of sigma. So you just have to choose the option that is withdrawing. If they ask about the negative effect, then you have to choose that it is having the electron donating substitution. So student, we had done with the 14th question. Now I am remaining with the 4 to 5 questions more. So this question for you. So which compound is known as 2-pyrroline? So 2-pyrroline, as I had discussed earlier in the many reference session, 2-pyrroline, that is the compound having the double bond at the second position. So there is only the single option. This is the option in which you are able to select. This is the first atom of the ring, and this is the second carbon, third carbon, fourth carbon, and fifth carbon. So 2-pyrroline means there is a double bond at the second position, and this is the only option in which you are able to see the double bond at the second position. So pyrroline, that is having the name of your dihydropyrroline, it is having the 3 different heterocyclic organic complex that differ in the position of the double bond. So it is an aromatic pyrrole. It is derived from the aromatization of the pyrrole by the hydrogenation. It is also known as a cyclic amine, whereas 2-pyrroline and 3-pyrroline are the cyclic amine. It is a cyclic amine when 1-pyrroline, as well as 2 or 3-pyrroline as your cyclic amine. Got it? So next question for you, that is very interesting question for everyone. There will be a probability that this type of question will ask in your upcoming Telangana Pharmacist examination. So you don't have to skip this question. So what is the question? how many significant figure are there? How many significant figure are there? So we have 0.005, we have 0.005 and 00. So in this there is only we can say four significant figure we have. Four significant figure we have, like there is a rule for this question. We just have to skip these the leading zero, means 0.00 are not significant figure, because they are just only used to indicate the decimal placement, because just we are using to indicate that this about after these decimal places there is a number, and the digit like 5000, like after 5 we have the 30 that are used for the measurement. So we can say in this given questions we have the four significant figure. Got it? Next question for you: which reagent is used for the limit test of lead? Limit test of lead, which reagent is used? So if there is a question of the limit test, so we just have to remember that we have limit test of chloride, sulfate, iron, lead, heavy metal and arsenic. So arsenic, that is basically related to the Gurjet apparatus. Chloride, that is nitric acid. Sulfate, that is barium sulfate, barium chloride, potassium sulfate. We have the iron limit test, that is basically citric acid and thioglycolic acid. Phenol red, that is also used in your lead test, but the main reagent, that is your diathiazone, that is used in the limit test of lead. So lead limit test is basically reaction between the lead and diphenyl thiacarbazone, that is chemically a diathiazone. It in alkaline solution it forms the lead diathiazone, that is having the red color, but primarily the diathiazone is having the violet color and at the neutral stage. So sorry, green color in a there we can say itself diathiazone is having the green color, but lead diathiazone it form the violet color. So net result color become red after addition of your phenol red. As I told you that phenol red is also used in this limit test, but it is not a we can say main reagent. It is just add to contrast the color. So this is the typical representation of your lead test and lead test of limit. We have the lead, and after that diathiazone. As I told you, diathiazone is having the green color and it is having the chemical composition, that is diphenyl thiacarbazone. As we are using the alkaline medium and there is a formation of a big complex that is having the red color. So they will ask like many questions about the diathiazone chemical composition, that is diphenyl thiacarbazone, color of the end product, that is red color, color of your diathiazone, that is having the green, but lead diathiazone is having the violet color. So among these from this slide they will ask 5 to 6 questions, so you have to clear about the each and every lines that I am discussing right now. Next question for you, just we are remaining with 2 to 3 questions more. So pyridine is a 6-membered ring, pyridine is a 6-membered ring containing the compound which contain carbon and nitrogen. So as you know, pyridine, I told you that is the 6-membered ring, and I don't think like you just have to take more than 2 seconds for this question. If there is a question like pyridine, so in your mind the option is like that pyridine, that is the 6-membered ring having the nitrogen as a heteroatom, it is a aromatic compound. If it is written that there is a 5-membered compound having we can say nitrogen as heteroatom, what we can say, it is pyrrole. If 5-membered heterocyclic compound having the oxygen as a heteroatom, it is furan. If it is thiophene, if there is sulfur. So pyridines is having the containing the 5 carbon as well as the 1 nitrogen, and chemical formula you are able to see that is written here. It contains 5 carbon, 5 hydrogen and 1 nitrogen, and it is structurally related to our benzene, and it contain we can say nitrogen as well as the carbon. So second last question we have, in alkalimetry which type of substance are typically titrated? So alkalimetry means like there is an alkaline medium. So in alkalimetry we are just titrated the acidic, but in acidimetry we have to titrate base. So in this question just they are asking alkalimetry we are just titrating the acid, but in acidimetry we have to titrate the base. So definition of you have the acidimetry. So acidimetry, that is used to determine the concentration of the basic substance and using the standard acid. Next you have like the sample that you choose for the acidimetry, like your ephedrine, your adrenaline, caffeine and acyclovir. Like the any drug that is having the end with the ine, any drug, either is the amlodipine, it's a nicardipine, I and E in land of the drug means it is a basic drug, whereas our nalidixic acid, your 5-fluorouracil, that is your basic drug, and sorry, acidic drug, that is used for the alkalimetry. And the indicator that we are using for acidometry, we have crystal violet, that is in the 0.5% glacial acetic acid, and it changes the color from the violet to the yellowish green. So there is a change in the color from the violet to yellowish green. And in case of alkalimetry, we are also using an indicator that is having the uh, indicator like thiamol blue in the concentration of 0.5% of thiamol, and the color changes pink to blue. So you have to remember that indicator crystal violet, that is from the violet to green, and in alkalimetry the indicator is thiamol, that is pink to blue. Pink to blue in alkalimetry. Alkalimetry we are choosing acidic drug. Acidometry we are choosing as crystal violet having the basic drug, and color change from the violet to yellow green. Last question for today's discussion. The compound that bring out protein precipitation are called. As I told you in the earlier questions, in which there is like a question of the stannous fluoride, that protein precipitating agent are our astringent. So astringent are applied topically to give the protein precipitation. They cause the contraction and wrinkling of the tissue and reduce the cell permeability, and constrict the local blood vessels and inhibit the transparency movement of the plasma and proteins. So this is the typical questions that we like. This is the typical we can say explanation of your astringent. You just have to remember all the topics point that I had covered in today's session. And if you are having any doubt, you can just ask me anytime. Just drop a message. So I hope you had enjoyed this session also. And to know more, stay connected with me and GDC for the next part of your pharmaceutical chemistry modules. So thank you. Have a good day. All the best for your examination. Thank you, everyone.